All right, this is Introduction to Circles 9.2 in your books, and, well, may not be the circle of life, but circles are going to be your life for the next 3 weeks or so. So I thought this would be appropriate to get you in that mind frame. But we'll move on past that right about now. All right, so let's start off with our objectives. We actually only have one, and that is to begin solving problems using circles. All right, and so we're just going to be doing the basics today, nothing too heavy, so you'll like that. Let's move on to some vocabulary, shall we? Circumference is the perimeter of the circle, so it's a measurement of the outside of the circle. Okay, and we use the formula C equals pi times d, where C is circumference and d is diameter. If you're given the radius, you can either just double it, or you can use the formula C equals 2 pi r, where r is the radius. So just another way, it's the same formula basically, it's just another way of thinking of it. Okay, area, which we're really not going to use this chapter a whole lot, but I thought it was important to kind of touch on anyway. And area is found using the formula A, which stands for area, equals pi r squared, which r is the radius, as you know. But again, not going to use it a whole lot. All right, and a chord, you're going to see this come up a lot. A chord is a line segment joining 2 points on a circle. So on a circle means, I'm going to draw a real crude circle here. Okay, on a circle means on the actual outside of the circle. And when it's joining those 2 points, it's the segment that joins those 2 points. So that would be a chord, okay? Which is different from an arc, even though it sounds kind of the same. An arc is made up of 2 points on a circle, and here's where it differs. And all of the points on the circle needed to connect those 2 points by a single path. So you're basically following the curve of this, or the arc of the circle. So let's say we have our circle here and we have points A and C. This here would be the arc that connects A and C, and we would symbolize it as arc AC. So similar to a segment, this is just an arc over the 2 points that make up the arc. Okay? So now finding the measure and the length of an arc. There is a difference between measure and length, okay? So you've got to pay attention to the wording of these problems. This is extremely important right here. Okay, the measure is the number of degrees out of 360 that the arc occupies on the circle, because remember, there's 360 degrees in a circle. So now, these next two things are going to be easier to see than it is to write down and understand. So I'm going to do my best here. So if the segments that intercept the arc are radii of the circle, the measure of the arc is equal to the measure of the angle formed by the radii. So I'm just going to draw a small little circle here. And a radii, remember, comes from the center. So whatever this angle is in here, this arc would have the same measure. Okay, so if this is, say, an 80-degree angle, the arc measure would be 80 degrees. Okay, now if the segments that intercept the arc are chords that form an angle, meaning they meet at a vertex on the outside of the circle, the measure of the arc is twice the measure of the angle formed. So an example of that, so we've got our circle, and I have a point on the outside of the circle. There's one chord, and then I have another point on the outside of the circle that forms a vertex with this right here. Okay, so let's say that this is 30. This arc measure would be 60. So remember, this out here, this would be basically 2x, and that'd be x, whereas these would both be x. You get the idea, though. All right, now length. The length is the length of the arc on the circle, so that measurement of that curve shape between 2 points. And we use the formula, the measure of the arc, so that's where this comes in, over 360 times pi times diameter. Simple enough. All right, now sectors. Again, something that you're probably not going to be tested on, but I will throw some of these in for the quiz. So a sector of a circle is a region bounded by 2 radii and the arc of a circle. And the formula for that is the arc measure, so there's where that comes in again, over 360 times the area of the circle, so that pi r squared. All right, so let's try a practice problem. Find the circumference and area of circle P. So we find the circumference using pi times d, or circumference equals 2 pi r. In this case, we have a radius. So if we double that, we get pi times 5.4, and our answer would be 5.4 pi, or about 16.96. It depends on what they're asking for the answer in. So just be aware that if they're talking about rounding it to the nearest tenth, then use the this right here, or hundredth or whatever. If they just ask for the answer, then you can by all means leave it like that. Okay, now area is pi r squared, so we just plug that 2.7 in. And if we square just that, not the pi, just the 2.7, we get 7.29 pi, or about 22.9. All right, now let's try this practice problem. We're given that PR is a radius, so this part here is a radius of circle P. Find the measure of angle X and the length of NR. So N is actually up there. So, all right. So first, the measure of angle X. Well, we know that because of what I said about chords and when they form an angle, if this is 30, then this arc measure here, the measure of this arc, is 60 degrees. 2 times 30 is 60. So if this is 60 degrees, remember this is formed by two radii here, that means that this is equal to that. So the measure of angle X is also 60 degrees. Now remember, we're asking for that answers this question, but we're asking for the length of NR. Okay, not the measure. The measure we had, we needed to find. Now we're asking for the length. So we take the measure of the arc over 360 times pi times d. So the measure of the arc is 60 over 360 times pi times 12, because as you can see from here, r is at 60, and this is right on the point of origin. So that means that this radius is 6. So the diameter is 12. And we can simplify 60 over 360 to 1/6, and you can actually reduce across here without even having to worry about the pi. And you could say the length of NR is 2 pi, or if it's asking for a specific measurement, about 6.28. All right, so that about wraps it up. There is obviously more to come. I said this is a longer unit, and I meant it. This is going to take us right up to spring break. So make sure you take really, really good notes. All right, see you in the next video.